Okay, we are going to continue on with section 2.2. We have just defined these new functions that are made by adding, subtracting, multiplying, or dividing known functions together, and we've talked about how to calculate those and how to evaluate them if you're given what the value of x is. Now let's talk about what the domain of these functions are. So let's start with if you add, subtract, or multiply two functions together. The domain is simply the domain of the two where they intersect or where they overlap. So it's all of the numbers that are in both the domain of f and the domain of g. So if there's any numbers that are excluded from one of those two functions, then you exclude it from the domain of f, the sum, the difference, or the product. So let's go ahead and calculate that first in our example, and then we'll go to the division. We'll see how it's a little different for that. So let's start with finding the domain of f plus g, f minus g, and fg. And to do that, we're going to start by finding the domain of f and the domain of g, and then we'll combine those to get, so the domain of f. F is the square root of x. So what numbers could x be? And it's going to be defined. Well, we're talking about just in the real plane, where some of you have already learned about imaginary numbers. That's something we're going to get to later. When we're talking right now about our two-dimensional coordinate axis, we are talking about real numbers. So what numbers can you take the square root of and get a real number? Well, that's 0, 1, 2, 3, and all the fractions and decimals in between. So it's x is greater than or equal to 0. And I know my math lab sometimes asks you to write this different ways. It might ask you to write that in interval notation. You would use a square bracket on the 0 because we're including the 0. Infinity always has a round bracket, so that's all the numbers from 0 and greater. It might ask you to write it as an inequality, which would be how we did it originally. Sometimes it writes it like this, x such that, and then the inequality. And then, of course, sometimes you're asked to graph your answer. And I tend to do a solid circle for the number that includes, but I know my math lab, instead, it's going to use that square bracket instead. So let me make that a little bit neater. I kind of got messy there. Okay, so we've got our point 0, and we're going to have a square bracket, and then we're going to go out to the right because we're wanting the numbers that are bigger than that. And I think in my math lab, usually these are multiple choice where they give you several different graphs. Okay, let's look at g of x, domain of g. Domain of g. What numbers can't... Let's ignore for a minute that we have x minus 3 inside the absolute value. Let's just think about absolute values themselves. What numbers can you take the absolute value of and get a real number? Well, if you think about it, really anything. If you have a positive number and you take the absolute value of it, the answer is the number itself. Absolute value of 0 is 0. What about our negative numbers? Can you take the absolute value of 3? Well, of course you can. Absolute value of 3 is positive 3. Absolute value of negative 5 is positive 5. Absolute value of negative 1/2 is positive 1/2. So you can take the absolute value of any numbers, and so even though inside these absolute values we have the x minus 3, it really doesn't matter. All numbers are in that domain. So how do we write that? Well, if we're doing interval notation, it would be negative infinity to infinity. You might just write all real numbers. Or on the number line, of course, the whole thing is just going to be filled in all the way from one arrow to the other arrow. Okay, so let's start with this first part. Find the domain. Oops, I need to change back to a pen. Domain of f plus g, f minus g, and fg, because we know those are the same. So to find the domain, up here in our definition, the domain of f plus g, f minus g, and fg is the intersection of the domains of f and g. So we found the domain of f and g. Where do they intersect? What numbers are in both the domain of f and the domain of g? Well, everything's in the domain of g. So the only thing that limits it is that domain of f, which is that x has to be greater than or equal to 0. So that is our domain of those three new functions. And again, we could write it all the different ways that we did up above. Now let's find the domain of f over g. This one's a little more complicated, and so let's read the second part up here. We kind of stopped right here last time. The domain of fg is also the intersection of f and g, except we have to take out the places where g of x is 0. So here is our g of x function. So out here to the side, let's just do it right over here. Let's find where is g of x equal to 0. G of x is absolute value of x minus 3. So let's again just kind of, whenever I'm dealing with things like absolute values and square roots, I try to ignore what's inside and just think about if I was just taking the absolute value of a number, what numbers have an absolute value that's equal to 0? Well, there's only one, right? The absolute value of 0, or absolute value of 0 is 0. So what numbers could be in? Okay, so if x minus 3 is 0, then we get, by adding 3 to both sides, we get that x is equal to 3. Now remember, this is the number we do not want. We do not want x to be equal to 0. So combining our two pieces together, it's the intersection of the domain of f and g, so that would be what we just did up here. X is greater than or equal to 0, but x is not equal to 3. So if we think about that on a number line, we have x is greater than or equal to 0, but not equal to 3. So it's kind of like there's a round bracket there, and it's what's filled in here. Round bracket there. Or if you do it with the circles, that would be an open circle at 3. So we have two different sections here, which would start with 0 up to 3, not including 3, union with 3 going out to infinity. Okay, find the domain of g over f. So notice this, I just switched it around. Now, why did I not have you do g plus f, g minus f, gf? Because the domain of those are all going to be the same, right? Because if you add two functions, it's the intersection of the domain of the two. It doesn't matter which one you're adding to the other, or subtracting or multiplying. But for the division, it does matter because it's the one in the denominator that cannot be equal to 0. So when I switch this upside down, we now have, trying to change colors. There we go. Forgot how to do it. Just to make it a little easier to see here. Now notice we have g on top, f in the denominator. So it's just the reverse of here. So instead of f of, or g of x not being equal to 0, we have to make sure f is not equal to 0. And f is the square root of x. When is that equal to 0? Well, what numbers have a square root equal to 0? 0 itself. So x equals 0. Now again, this is the numbers we don't want. So it'd be kind of like they're not equal to 0. So what is left when we combine our domain of f plus our domain of g? Intersection of those is x is greater than or equal to 0, but now it says x cannot be 0, so we're left with it's the numbers greater than 0, not greater than or equal to. Or if you're putting that in interval notation, it's going to have a round bracket at 0 out to infinity. And again, graphing 0, that open circle or round bracket, whichever way you like to do it. I think my math lab likes the brackets. That's what the graph of that would look like. Okay, again, I want to say any questions, but definitely do ask if you have any. Okay, let's go ahead and talk about one more thing before we wrap this up. A line that is drawn between 2 points on a curve. So we've got this picture here. We've got this curve coming down. So the green is the curve that we're talking about. And we're connecting 2 points that are on that curve. Since it is a curve, that straight line doesn't follow the curve, but it connects those 2 points. That is called a secant line. S-E-C-A-N-T. I think that print maybe is a little easier to read. Okay, it's a secant line. And we can find the slope of that line. And when we find the slope of that line, this is actually definition. I probably should have capitalized this. That's called the difference quotient or the average rate of change. So whenever you see those words, difference quotient or average rate of change, there is a formula for that, and that's the slope of this line. So I did a little labeling here on this line. This first point we're going to call x, f of x. So that's our point f of x. Now, if we go over some units, and we'll just call it h, we would now be at x plus h. So I've just added h on. We have a second point that is h units bigger. So again, this is just making it general. Instead of, we could do this with numbers, and we will do it with numbers pretty soon, but doing it in general first, we're starting at one point x. We're going over and adding something to it to get a new x, which is x plus h, and go up. And so this point is going to be the y that's associated with x plus h, or f of x plus h. So remember that notation. Whenever you have that f, or it could be g, like we just did some problems where we had g, whatever's in that parentheses, it means you're going to calculate the function at that point. So this is just our x's and our y's. X, and then the y is f of x. Our second x is x plus h, and the y for that is x plus, or f of x plus h. So if we're calculating the slope, this is the formula you need to know. This is the slope calculation. Is called the difference quotient whenever it's the secant line. We're going to subtract the y's on top, just like we do. Remember, when we calculate the slope, we take y2 minus y1. So on the top, we're going to do f of x plus h. That's our y2 minus, I'm not sure why I'm having trouble writing all of a sudden, f of x. And then in the denominator, we're going to subtract our x's, and our x1 is x, our x2 is x minus h. So in the denominator, we get x plus h, that's our x2, minus x. And what do you notice? Here in the denominator, we have x minus x, so those can cancel out. So the formula that you're going to be using whenever you're asked to calculate the difference quotient or the average rate of change is right here. Just circle it in blue so it's easy to see. This is the important thing. So put a little asterisk next to that so it's easy to find when you're asked to use it. So now we're asked to find and simplify the difference quotient for, and then we're given a function. So we're just going to plug in here. So our formula is to take f of x plus h minus f of x over h. So f of x is 5x plus 3. That's what we're going to put here for f of x. F of x plus h, we have to replace the x with x plus h. So 5 times x plus h plus 3. Okay, that's f of x plus h. You guys see where I'm getting that? Okay, minus f of x. F of x is 5x plus 3, and I'm going to use parentheses just to make sure we remember we're subtracting that whole thing, 5x plus 3. And that's all over h. And now we're just going to simplify. Get rid of our parentheses by distributing. Now I can combine all of my x terms. I have a 5x and a minus 5x. Those cancel out actually. I get 5h. 3 minus 3, those cancel out as well. So our numerator is just 5h. Our denominator is h, and we end up with just 5. Okay, that is it for section 2.2. And by the way, this concept we just talked about here with the difference quotient, this is a big concept for calculus. So those of you that are going on to pre-calculus or calculus class, you'll get very familiar with this. So it's something you'll use over and over. Okay, that's it for 2.2. Do ask if you have questions. Keep up with your homework, and I'll see you when I see you in the video for 2.3.